Hi, everybody. Thanks for coming out. I guess headphones on, or if you can hear me, even better. It's up to you. Get started. I really appreciate everybody coming out on 5:30 on a middle of the day. A lot of fortitude. I mean, these are long days. Sticking with us to this long. I'm Carl Meadows. I run product management for Amazon Elasticsearch service. I'm also responsible for the product side of Open Distro for Elasticsearch, which is the open source project that we've been sponsoring that's driving a lot of the features that go into Amazon Elasticsearch service. Who here uses Amazon Elasticsearch service? A good chunk. Who here is actually knows what Open Distro is at all? Open Distro for Elasticsearch? Okay. Well, this isn't the session for that, but I'll just quickly mention it because they mention it in their slides. Open Distro for Elasticsearch, you're welcome to go look at. It's an Apache 2 licensed distribution with a bunch of additional features we layer on top of the open source Elasticsearch, including things like security, alerting, SQL support. We just added an anomaly detection capability to Open Distro that's in alpha. You can go take a look at. And all of those features, we then are rolling onto the service. So when they mention that, that's what they're referring to. So like I said, I'm here just to kick things off, give you a little bit of an overview. I'm not going to take up too much of your time. Want to make sure that we save plenty of time for Sophos, which I'm super excited to have great customers like them, especially willing to come out and talk to you guys and share what they've learned and with you. And I hope you guys really enjoy it. So before we dive into the whole thing, one of the things why Elasticsearch is becoming so popular is it's good to sort of take a step back and look at things. I think what we all see is there's a huge explosion in machine-generated data, and that machine-generated data is becoming increasingly important to operations and security and even the business for being able to have real-time access to it to more quickly resolve issues and make business decisions. So that's being driven by things like the trend to DevOps, the move to microservices, the move to more cloud-based architectures where you don't have direct access to your hardware. All of this is driving data. And while that's happened, there have long been good analytical tools out there for dealing with streaming machine-generated data. But many of these are commercial, and they're fairly expensive. And if your data is growing by 3x a year, people can do math. It starts becoming really expensive. So the Elasticsearch was kind of in the right place at the right time for being an open source technology that was being a search engine and having aggregation capability and bucketing and visualization capability with Kibana was really well situated to be an open source alternative to some of these commercial tools. And that, along with just being a good search engine, has driven a lot of its success to why we keep hearing about it, why it's become nearly ubiquitous. So like I mentioned, Elasticsearch is often coupled with Logstash, which is used for transformation and in buffering, and Kibana, which is used for visualization and dashboarding of that analytical data. It's distributed, it scales out easy, it's easy to get set up, it's easy to scale, not necessarily totally easy to run, but that's a different question. And it's super convenient. So there was so much demand for Elasticsearch and this, adding from our customers, we built a managed service, which is Amazon Elasticsearch service. And it runs the open source Elasticsearch plus some of the additional features that we've built on top of the service via Open Distro, as well as other capabilities we offer that make it easy for you to deploy, manage, and scale Elasticsearch. And it also includes a Kibana endpoint as well. If you think about the benefits of Amazon Elasticsearch, it is open source Elasticsearch. It's fully compatible with the open source tools and clients and ecosystem out there of Elasticsearch. Makes it very easy to use. It's scalable. You can set up a single T2 instance for a dev box all the way up to a 200 node i3 16XL environment supporting 3 petabytes in a single cluster. It's secure. It includes direct IAM integration, as well as VPC integration, encryption in flight, encryption in rest. has high availability options, including 3 AZ support, and it's very tightly integrated with the rest of the AWS ecosystem. So Kinesis and CloudWatch and IAM and CloudTrail. So it makes it very easy to build into your solutions. And we provide the same AWS support with the service, so you can have a single support experience across your AWS environment. So like I said, I didn't want to go on and make this just a pitch about Elasticsearch, but I did want to give you guys a quick introduction, and most importantly, I want to bring on stage who you're really here to see, which is Dennis Griffin is going to give you an overview of what they're doing, as well as a demo with Sophos, who's Director of Engineering, and then Key is going to talk to you guys. He's a distinguished engineer at Sophos. So I'll be also here afterwards to have any questions about the service and help you guys with anything you may need. So with that, I'll hand it over to Dennis. Thank you so much.
Thanks. So my name is Dennis Griffin. I'm the former founder CTO at a tiny cybersecurity company called Darkbytes. We joined Sophos earlier this year, and nowadays I run the engineering team for the Managed Threat Response Service, which is Sophos' first managed security service that does threat detection, incident response, and containment using a 24/7 staff security operations center. We use Elasticsearch very heavily. We always have. We have about 15 microservices in Amazon that runs across 4 different regions globally. And we ingest tens of billions of documents every single day into those clusters. So today we're going to talk a little bit about how we use it, why we use it, why it's good, and some of why it's maybe not so good. So there's a lot of different databases that you can use building a security solution. And just to name a few that we use within our platform, RDS, DynamoDB, and Elasticsearch. And we even have some MongoDB. In general, I think that there's pros and cons to the different databases. NoSQL in particular is really good for the stuff that Carl mentioned, ingesting a large amount of machine-generated data that you need to analyze in real time, store in time series, and perhaps that data might change a little bit more dynamically than what you would want to handle in, say, a relational database. We chose Elasticsearch instead of MongoDB specifically because of the ability to search. Fundamentally, we are looking for a needle in a haystack. We generate tens of billions of documents every day, and maybe 1 million of those or less is interesting. And of those, maybe 1,000 will actually get escalated to a person that needs to look at it and investigate and take action. So in order to do that, we need the ability to take that data in. We need the ability to change it very easily to reduce signal-to-noise ratio. And we need the ability to pull it up in a way that is performant and scalable. So when it comes to NoSQL, there's actually quite a few choices. The 2 most popular today are MongoDB and Elasticsearch. MongoDB was really built to be a general-purpose database and document store. It does a lot of things really well, but unfortunately, there's no hosted service for it from Amazon. We use Amazon very heavily. We use a ton of the services, and we're a relatively small engineering team. So we don't want to spend our time doing operations, scaling clusters, debugging things through logs, or anything like that. We want to be able to focus our efforts on building value through security analytics. So the nice thing with Elasticsearch is that you can really get started with it in like 1 click. It's super easy. Basically, you go into the console, you can press a blue button, select your instance types, and you have a cluster up and running in like 5 minutes. It's very simple when it starts off. The other nice thing about it is if you need to do upgrades. Generally speaking, upgrades are pretty easy in Amazon. Again, it's a blue button that you can click most of the time. Occasionally, if you use, say, Amazon 5X and you're upgrading to 6X, and you might have something like multiple document types in a single index, well, that might be a little bit more of a hard migration because the technology of ES itself was not a backwards compatible change there. So most of the time, though, the actual operation aspect of it is pretty simple in Amazon. The other nice thing about it is the maintenance is pretty minimal. I think as long as you have a reasonable structure to your documents, you're using Elasticsearch and how it was intended to be used, and you don't do some crazy stuff, it's pretty easy. Now, in the world of machine-generated data, where you don't control the data source, and you're ingesting a ton of different information and analyzing it in a ton of different ways, it's a little easier said than done. So sometimes you will find people who do things that might take your cluster to red status, for example, and that does happen. The other nice thing that I like about it is the ability to scale it is increase a number in a box. Basically you can increase it to a huge instance type, vertically scale it. You can add storage through EBS. You can use instance-based storage with SSDs. You can just add more nodes. There's a million ways to scale your cluster and to basically make it more performant without having to have downtime, without having to worry about migrating your data. It just makes it very, very simple to scale operationally. And it's very secure. For someone like us who uses mostly Amazon-based services, a combination of EC2, Lambda, et cetera, being able to integrate with IAM makes all of our different security aspects, access control to Elasticsearch pretty much seamless. It's just like authenticating to DynamoDB or any other Amazon service. Now, there's a couple things that maybe are not so nice. There is limited access, since it's a managed service, to the cluster APIs. So if you were to self-host and deploy your own Elasticsearch, you would have full control over all the cluster settings. You could write them. You can pretty much do whatever you want, including shoot yourself in the foot. And as a result of that, there's not necessarily all the flexibility that you might get for tuning a cluster through those APIs in the service. You can get a lot of the different metrics for monitoring the cluster. That does exist. So you do get some read access, still have some of that visibility, but you don't have control over the settings. If you're a Linux guy like me, you might want to see, on a given node, why it's freaking out so you can take it out back and shoot it, right? Because it's taking down your entire cluster. Well, if you want to do that with a managed service, you basically have to open a ticket and wait, because you can't SSH into the nodes. All you can see is the CloudWatch metrics. So you might know it's having a problem, but you can't necessarily take action to it unless you try to either redeploy or change an instance type to force a redeploy. So some of the times when things do break, which is inevitable in these workloads, you have to basically open a support ticket and wait for Amazon to help you a little bit. So we'll talk just a little bit about how we use ES. So we run the Managed Threat Response Platform team, which is consumed by a Security Operations Center. And fundamentally, what we do is collect data from external sources. Primarily, we use an endpoint agent from Facebook called OS Query, which exposes your operating system as an SQL database. And then we have about 50 some odd queries to collect everything from processes, network events, Windows events, registry settings, file events, amongst many, many other things. We take all that information and we send it up into our cloud. And we then basically process it into more meaningful security events, which we call detections. So threats, vulnerabilities, compliance violations, things that are interesting to security teams. So we have a very large pipeline that takes all that data, processes it, figures out these detections, and guess what? It puts it back into ES. So all that stuff ends up going there. We also ingest data from other sources, like the XG Firewall, or the Sophos Cloud Optics products, or Active Directory, amongst many others. And so all these other types of data that are not necessarily from OS Query also come to us and ultimately go into Elasticsearch, which we use in our UI. So once we get this interesting information, our security team does rapid response as well. So we provide a case management system where they can document what happened. They can put all of their findings, publish it to a customer to show them what's happened, and all kinds of different workflow-oriented things you need for a SOC. And then we have the ability to do automated response through playbooks, where you can have security automation code automatically contain and remediate issues, and also secure remote access through a live terminal, which is driven on WebSockets. And again, all that data has some kind of information that we typically put in Elasticsearch, because most of it we put in time series. So fundamentally, MTR is search. We have a huge set of data. That data is of varying types, of varying interests, and a varying signal-to-noise ratio. The question is, how do we find the data that's interesting? And that's where Elasticsearch helps us a lot. It allows us to store everything in time series, so we can then aggregate and look for anomalies. It allows us to aggregate data and look for uniqueness in data. It allows us to search data and find things very specifically, like with free text search, wildcards. So for example, if I wanted to find anything that was maybe a PowerShell command that has an uncoded command string, you can embed that in a query, and it's very simple to find that data. And finally, we can do all these things. We can add new aggregations. We can search it. We can add more data. We can basically beat the crap out of it, and it still works. It's performant and it's scalable. And that's the most important thing for us. So let's look at a little bit of JSON. OS query, like I mentioned, exposes an operating system as an SQL database. So when we receive the data from these queries, this is basically what it looks like. It has the name, in this case open sockets, a host identifier, which is a hardware-based UUID for that endpoint, and some other information that we can adjust dynamically based on the queries we provide to it or the configuration that we provide to it. So decorators allow us to add information to every single document that we receive. In this case, the host name and something called an endpoint ID. So this will be available for us in all of our documents. So now we can search it, filter it, aggregate it based on that data. And OS query makes that very simple for us to do. We also have something called columns, which is a free-form object. And it's determined based on the query that you created. So in this case, there would be something similar to select local address, name, remote address, and port, as the columns from some table. And this is the resulting document. So we have about 50 of these queries, which we'll talk about in a minute, and you'll be able to see what they look like. Once we have that data in ES, then we can use the search parameters within ES. Then there's a lot of different DSLs you can use. This is one of them, which is called query string. It's a Lucene formatted string that's very user-friendly. It allows you to do ands, ors, groupings, wildcards, a lot of basic things you might do to search and filter down data. And you can type it as an end user pretty easily. So in this case, we're going to basically look for anything that is decorations.hostname Dennis and within the past day. And we're going to sort it to put the most recent document on the top based on the field Unix time. And then in addition, you can take that same idea of searching and you can do aggregations. You can put it into buckets so you can analyze it better. And in this case, you would get 1,000 different buckets, if they exist, with all the unique host names. So you can filter the data and say, I want all the unique host names that ran PowerShell, for example. Or you could say, I want all the unique command line strings that are on someone's particular computer. And furthermore, you can nest aggregations and do things like get those counts and then do averages on all of those different unique buckets. Another very common one that we use is a timeline aggregation. A lot of the time in security, it's very easy to look at a timeline when you have a number of events to find out when something interesting happened. So when we store data in time series, our detections are 2 years retention period. Sometimes you're going to want to go back and find interesting information, say for an auditor or just for threat hunting or correlation. So we'll use timelines like this, which would basically give you a one-day interval. So if you had 30-day time range, you'd have 30 different data points on the graph to basically do that exact same thing. So I have a really quick demo, and we'll go through. I'll try to speak over it best of my ability. So when you log into our platform, you see something very similar to this. Got it. So we have a time picker on the top right, which you'll see in a moment. Oh, it was okay. Go back. I already played it. Oh, you did? Yeah, you're good. No worries. Oh. We'll figure it out. All right, we're back. Thank you for the technical assistance. I appreciate it. So we have a time range on the top that you'll see. Right now it's set to last 7 days. So you can pick this to any relative time range, like last 24 hours, or you can go pick a specific time range. And ultimately, this comes down into our search that we're going to put into ES. So on the dashboard, you can see a bunch of information about the hosts, the deltas, different threats that are there, the risk of the different threats across the endpoints. And these are all different ES queries. On this page, I think you might run 500 queries in one request. On this page, we drill down into a specific threat, and we can see all kinds of different context. So when you go here, we're going out and looking for things like related network connections, the process that launched, when are all the events that we found, when was the first time we saw it, when was the last time we saw it, and all kinds of information you need as a security operator to make an informed decision on whether this is malicious or benign. And that's ultimately the job that we're trying to do with Elasticsearch, is to pull that context in dynamically, regardless of the data type, because we don't just operate on processes, we operate on lots of things, and provide a UI that is fast and performant. So if you click down on that host that generated that particular threat, you can see all kinds of information. So these are the threats that existed within the last 24 hours. But if you extend it to 7 days, this is a much more affected host than you might think. And you'll see all kinds of things like Mimikatz, antivirus detections, processes that are running, malicious URLs that it's connecting to, amongst other things. These are all things that we've already detected and deemed that were more interesting than other data. Then you can get access to the raw data as well, like the network connections, listening ports, the process that opened those, the countries that they were connecting to, and a lot of other information that you might want to use for hunting. So say that you wanted to come here and look for anything connecting to China. It'd be pretty easy to pull it up. Or if you wanted to see a particular process, like in this case, PowerShell, and what it's connecting to. You can filter through that data and find it pretty easily. Another set of data that we use a lot is user accounts. If you want to see if an attacker perhaps added a user account locally as an administrator, that would show up here. And then you'd be able to say, take that user account, search it, and pivot on that to see where else it's logged into. And all of these are different queries ultimately going to ES. So when you come back to the threat page, 2 steps back, we can also interact with it and run custom searches. So this is our search builder UI, which is one of the more easier UIs to use for these. And basically what that did is it took that information, the host name or the host identifier and the process, and said, let me go run this search for you. It built the information. And now this is going to Elasticsearch and showing you the running processes that match that information, and now taking slightly longer, because the data set's quite a bit bigger, the open sockets, so all the network connections that were also generated by that. And now you can see this really nice base64 encoded string that looks totally normal, right? So all this information, when you scroll very far right, you'll see even the IP addresses that it connected to, the ports that it connected to, amongst other things. The other search component we have is a lot like Kibana, a little more raw. It's actually like the Kibana dev tools. That's probably the best way of putting it. So you can create your own raw JSON query or use a templated one like this, just like I did earlier. And in this case, we'll look for, again, PowerShell.exe as a process name and search it. And this is going to give us all the documents, the whole JSON, for all of those different PowerShell processes. So as more of a power user, you might want to be able to come in here and get additional information. As you can see, there's quite a bit. The hashes, the process IDs, the parent process, and all the different decorations. And you can see all these different data points. This is the full document. The challenge becomes here is that obviously this is a very big document. If you had thousands of these, how would you ever look through all the command lines and figure out which one's interesting? It'd be a lot of scrolling, right? So that's where aggregations are super useful, especially from a user experience perspective. So we can do an aggregation on the command line, in this case, and get all the unique command line strings by using a terms aggregation. In this case, we're using a painless script to do that terms aggregation, but there's multiple ways to do that. And now we have a much more easy thing to look for. We can go and see the 4 different unique processes out of the N documents. In this case, I think like 6 or 7. And it's much easier to pick out the ones that are interesting and the ones that are not interesting. We also use the same kind of functionality to determine which ones are common or uncommon, just by looking at the cardinality of that. So taking a step back, if we look at the queries, the SQL queries that we send to OS query, this is kind of what they look like to generate that JSON document. You can see that we're selecting things like command line, the process name, the PID, the hashes, amongst many other data points here. Now this is just one query for processes. You can see we have quite a few sections here, including network, user, browser add-ons, patches. I think in total, we have ballpark 50 queries. We probably add 1 to 2 every 2 weeks. So it's growing at a very fast pace. Each of these queries generate a variable amount of data. They have variable fields. They have a lot of different nuances. And by the way, all this stuff is cross-platform. So if you want to do it across Windows, Mac, and Linux, that also provides that capability. So here's a more complex query that gets a little bit more out of hand. This one is going to basically get all the different IP traffic that is interesting. So stuff that is not, that's external, that's not common ports. And we're basically taking all this data and filtering it on the edge with this relatively massive SQL query. Now, the operators don't typically have to worry about these. These are kind of queries that we write. They're deployed the second someone installs our product. That comes up, and this is really what the operators would work off of, is the results that we're storing in ES. We typically don't want our analysts to have to learn SQLite in order to do their job. So ES provides us that capability to take the data, aggregate it, and put it into a UI in a way that's user-friendly and efficient for them to do their investigations, because for them, the time is money. We get hundreds of cases every single day. And with that, I'm going to go ahead and pass it off to Key. Don't press the black one.
Thank you. So everybody, thanks again. I know it's kind of like the end of the day and you guys are here and I really do appreciate it. So just a little bit of background about me. Prior to being at Sophos, I was at an email security company. I've been a really big user of ES for a very long period of time. At Sophos, we use it kind of in a bunch of different places for a bunch of different types of problems. And one of the challenges that you sort of run into in terms of using this is that it's an incredible technology to get started with. It's really, really easy to kind of deliver a bunch of value. And then once you start really using it and you wind up scaling up, it starts to lose its shine of being awesome. And I'm going to talk a little bit about how to keep that shine of being awesome on Elasticsearch for kind of the entire period of time. There's a bunch of things that you have to think about and you have to do whenever sort of setting up a cluster. Now, at Sophos, we have kind of a mixture of the way that we do things. We have a bunch of pieces that are sort of self-hosted, where we run ES internally for kind of different purposes. We use it in our labs environment for kind of threat hunting, where we sort of catalog all the threats that are out there and find their permutations. We use it for our MTR services that are out there. We also use it for like email archiving and being able to scan through and search those messages as they come about from that. When you're providing, or you're a team that's going to provide this as a service to the rest of the organization that they're going to wind up building interesting value on top of, there's a bunch of things you have to do to kind of protect yourself. And these are true of whether it's your own cluster or it's something you're going to get as a hosted service from Amazon. And the first part is really thinking about how are my users interacting with it. Everybody gives you the happy path of what they expect that to look like. I'm going to do this. The reality is that things change, and they change at the speed of business. And they may not tell you how those things are going to change. So it's critically important to monitor every single query that comes through. Not just the slow query log, not the errored queries. Look at everything. There are patterns that are in there that need to be analyzed, and you'll kind of get a lot of information that comes out of that. If you have any client applications, so Kibana counts as a client application, monitor it. Take a look at its usage, what it looks like, how many times do people actually connect to it. Think of it the way that you would your web applications in terms of an APM. Understanding those users and how you deliver that platform to them really drives that kind of capability of sort of going forward from that. Amazon has a list of recommended CloudWatch metrics that are there. These are things that you should look at actively. They will give you a tremendous amount of insight on the health of the service that you're running, because nobody likes to call at 3 a.m. And this is like the best way that's possible to avoid that. The other thing that comes into this, and it's been painful in the past, is upgrades. They do take time. They are an event that you have to do, and you should budget for them, whatever that looks like. The technology itself is really rapidly maturing. As Carl mentioned earlier, there's open distro. There's a lot of new capabilities that are kind of coming out. There's new places for you to deliver that value. Being able to kind of keep that as part of your cycle as you're delivering this as a service only allows you to kind of accelerate all that. And being aware of some of those things that are there. The other thing that's also important to kind of consider in terms of all of this is reindexing or realigning your data. It's not an evil word. It's a maintenance process. As the use cases change over time, as your users change the way that they interact with that data, the structure of that access pattern, either by the way that you ingest it or the way that they're consuming it, it's going to change. Elasticsearch is always at its best when you kind of align all of those things. So this becomes a maintenance event that you just need to budget for. If you build automation around that, this is something that becomes really painless. Like for us, we do this in different clusters in different places, and it's a pretty painless job. It just kind of runs as a background script, and it comes up from that, and it's there. So there's some other issues that kind of come up when you're running Elasticsearch for a group of people that are there. And in our case, there's some of these clusters that we run that we don't actually control the data that's coming in, and we don't control the way that users are interacting with it. So in a typical organization, you're going to see this kind of use case where you have a team that's responsible for Elasticsearch, and then they hand a bunch of operators Kibana, and then they hand another group of operators like a syslog endpoint. They say, you know what, I'm going to send a bunch of data here, and then I'm going to look for interesting events over there. And anybody that's going to set up their own kind of SOC, their own network operations center, it's just a common use case that comes up. There's a group of devs that are responsible for kind of keeping this thing up and running, and it's there. And there's some challenges that kind of come with that. One, Elasticsearch is a really easy technology to become successful with. But as a result, everybody wants to use a lot of it, and they want to send everything to it. And each one of those things becomes a mapping that you have to kind of control. Each one of those things becomes some technical debt or cruft if it's not being used. Each one of those things becomes something that you have to kind of manage and sort of maintain inside your structure from there. So when people want to do this, it's really important that you understand at least what the impact of that data is within your cluster, and you're looking at what it's doing to your mappings. And you want your mappings to be really dense. You don't want them to be sparse. And I'll show you an example of what that looks like and why that needs to get there. You should also think about how you kind of derive your indexes. There's data, like Dennis showed in his examples, that logically goes together. You're always going to consume it together. It may always come in together. So you don't get these sort of fragmented updates. You don't get kind of a use case where you have to try to stitch together multiple sources of data from there. And if you keep these in limited indexes, you have the ability now to sort of take the best advantage of your cluster. You can group the memory based on your search performance, based on the indexes that are being targeted, and your users will get a much better experience. It'll just be faster overall. The other thing that you want to do is you want to think about how your users interact with sort of the search interface from that. The indexes themselves, if they're grouped, the naming becomes part of the sort of search capability that becomes in that. And if you use kind of common prefixes and a good sort of naming structure around that, you can make that practice of kind of going across different groups of logical data very, very easy for your users in that sense. So let's take a look at like what a sparse index is. And the concept's really simple. You know, it's basically when you have a mapping that exists somewhere and you have a bunch of null fields that sit around in there. And around 6.6, they made some really big improvements in the way that they handle this. But in the past, you pretty much had to absorb an entire block in your storage, and when that block was retrieved into memory to be cached or as part of your search, you kind of ate the cost of it. So when you had these sparse indexes, like your search performance would just get really slow. Your indexing performance, because sometimes when you're not just doing a straight insert, but you're kind of attaching to another document, that also becomes really slow in terms of all of that. So the idea in kind of looking at this is to sort of look at the structure of that and say, okay, if I don't have certain columns all the time in certain places, can I use the common prefix of maybe like the user ID in this particular case and have multiple indexes that have different pieces of data so that when I need all of the data, I can search across multiple indices. But when I don't need all of that data, I'm only searching across a few, and I'll get greater density with inside each of those indexes, even though I have multiple indexes running against it. The next piece that comes up, and it's really in kind of the security space that we really hit this pretty effectively, is this kind of mapping explosion. Elasticsearch within inside a document has a limit to how many fields it can kind of throw in that. And when you think about a lot of security applications, especially older protocols that are out there, there's like hundreds, thousands, tens of thousands, hundreds of thousands of different distinct things that they're there. Wireshark is a common example. I get this question from a lot of people where they're like, yeah, I'm going to set up a span port, I'll put on a machine, I'll run Wireshark on it, I'll connect it to Logstash, and I'll dump it in ES, and I'll have every network event that happened within my network, and we'll be safe. The reality is that you're just creating a giant haystack of a lot of needles that aren't really going to be useful to be found. It's going to probably blow up your cluster, and nobody's ever going to sift through that data, you know? So don't do that. Pick the things that you want. Be really judicious about what that looks like. And again, going back to the monitoring idea, think about what's in there. If you have data that's being stored that people aren't using, maybe it doesn't need to be in there. Or if it is useful and it's very, very periodic and when it needs, maybe don't store it in ES. Just put a reference to it somewhere else. We do this often when we have big data bags. We just create an object in S3 and leave the reference to S3 inside Elasticsearch where we can retrieve the relationship to that object, but we don't actually have to store the object inside our Elasticsearch cluster where it's more costly, it kind of impacts the performance of things. And there's an API that you can use called mapping that allows you to see what all these index mappings look like. it's worth monitoring. It's not really one that people chase all that often. We find it immensely useful because it's an instant indicator of changes to the document structure within inside an index and how they're going to actually be used within inside the cluster itself. So it's a great one to put in. We actually do something creative with it. We grab that API and store it in a different Elasticsearch cluster. So it's easy to aggregate across, and we can see a timeline of kind of how it's changed over time. You know, it doesn't take a lot to be able to look at this stuff, but actually looking at the data is really, really important to kind of get very successful kind of use out of all of this. So the second issue, and this is one that it's like a blessing and a bane in my life, kind of on a day-to-day basis. I have a lot of great users. They're doing really valuable things. The trouble is that they don't really understand when they're trying to do certain types of things, what impact they have on the cluster and maybe to their neighbors that are all of that. Logically, I'd love to be able to move them into different clusters. The reality is, based on their job function, that may not be possible. There may be a lot of times, like when you consider MTR users, they need a vast amount of data. They need to be able to look at it in multiple dimensions, and they need to be able to address the same cluster that's there. I can't kind of give them each their own. When they issue certain types of queries, and it's really these ones where you're kind of taking a lot of cardinal items and grouping by them and then aggregating across those groups. One of the examples that Dennis showed is like a great example of kind of when this sort of happens. All of that data that you're going to do, that you're going to basically aggregate and everything else, it's got to fit in memory inside the cluster. If your cluster is really, really big, you'll get away with it for a while. But as your data volumes grow, as the number of users of that particular service grow and you have more and more concurrency needs, at some point, it's going to fall over. So monitoring this early kind of prevents that scale problem later. So it's one of those things to kind of take a look at. The other one that winds up coming up quite a bit is when people want to be able to get a bunch of data out of Elasticsearch. It's just not a great technology for this. Someone will issue a command and they'll be like, ooh, I need all of this for a report. And they'll sort of run through it. And we're going to take a look at an example of what that kind of does of that type of query that's there. And then the final one is it's kind of really actually a failure of the data structure versus the data consumption. A lot of times when you kind of see certain types of fields, people will want to use wildcards as kind of the leading element of that in order to be able to get something. Well, do like star, foo, and then another star, and I want to get that kind of data. That's the kind of query that really you need to avoid in Elasticsearch. Now, there's a few API settings that you can use to actually kind of protect your cluster. And these are limits that at their default are maybe a little too generous. And you should take a look at your usage of your cluster and you should adjust these. And what they'll do is that when you have some of these queries that potentially are damaging or impacting the availability of the cluster, they put a time limit on it or they put a content limit on it to prevent that. One of the things you'll notice in like all of our really well-behaved queries, they all start with some kind of a limit that's in there. You know, search 10, search 20. They're not unbounded where they may try to like search the entire cluster with that. So I'm going to go into kind of a few examples of these, and you know, we can kind of take a look at some of the cases that they come in. So in this particular example, the user wanted to see how many times PowerShell was run on every computer and how many times it was run on those computers, and then he wanted to organize it by the parameters that were in the PowerShell script. This is one of those ones that's tough. As a user, they didn't understand that, look, every single parameter of every single permutation within that query, it's really unique. It's highly cardinal. So as a result, you have to now troll through all of the data in order to be able to sort of group it into buckets and then create your aggregation out of that. When you ran this query, there was no limit to the number of buckets that were kind of put in. So, you know, very, very quickly, the resource utilization started to grow. And our cluster went from really, really happy and very available and kind of doing its thing to this giant jagged line of doom, which just was not great. And that was definitely a service impacting kind of moment, triggered by one user trying to do part of their job in terms of running that. And I don't think they were bad for putting in the query, but the query was definitely bad. Another example of kind of the same thing, and this time using aggregations, is this time they want to be able to sort of aggregate events by customer, by type, you know, and then status. And then they want a grouping against the timeline on that. So now when you look at all of these are like aggregation after aggregation after aggregation, and they're all nested into these buckets. And if any of you use Kibana, that's when you get that really weird graph that it looks like a bunch of steps that go all the way down and sort of extend from that. This is another one of those things that if for each one of those nested queries, I have to create buckets of aggregation. And those buckets are going to be nested. And those buckets have to be held in memory the whole time that they're there until the user releases the query. If you have something in a scale of hundreds, this is not going to be a problem. You'll be able to run it every single day, and you won't really notice the difference. But once you start getting at kind of the scale of billions, and you're really looking for results that are grouped into millions, this becomes a real challenge. It's going to be very, very hard to build a cluster large enough that's sort of sustainable at that scale to kind of maintain those types of queries, especially because this is the type of query that when you really look at it, it's not driving a lot of value from a security standpoint. Like, it's kind of neat, and it makes a cool looking graph, but the user can't really come up with something actionable out of this. So it's the kind of thing that just needs to go away, or if you really need this and you have a use case for this where you're constantly looking at things in these kind of nestings, there is something called the nested data type, which will allow you to kind of retrieve this data and not have to absorb the aggregation in buckets. It's kind of the method that we need to use to sort of take a look at that. And here's a great example of something that happens all the time. Folks will name their computers or name their users in a pretty standard pattern. We see this all the time where someone has a domain, they have a function for a server, it might be a mail server, it might be something else. They put the region that it's located in, and then afterwards they have some kind of name, server 1, whatever. It looks really logical from a human standpoint. It's really understandable and it's easily readable. The challenge is that if I want to now filter something by either the function or by the domain that it's in, or by its region, I wind up putting in this leading wildcard. And as soon as I put in a leading wildcard in Elasticsearch, well, it has no context. It doesn't understand. So whatever indexes you targeted for, it's going to scan every single document in there to try to satisfy that request from the user. That's tough, especially if you have a big cluster with a lot of documents in it. It's one of those things you just want to avoid in general. So what we wound up doing in this case, because we didn't want to go back and rename all the computers and everything else in there, was really just adding tags with inside that. So we extended the document format with additional information. So at the time of ingest, we could read this on a single document, and then we could add a tag in there for region, and we could add another tag in there for function. So now when we want to query for those things, we're really only querying against that one static element and not against this kind of cardinal field that needs that wildcard. So this is one that we kind of run into all the time, and it's sort of the dreaded scroll. Someone needs a bunch of data. They want to export it out of Elasticsearch, and it seems really reasonable to sort of do that. The challenge that you have comes from really the underlying technology of how Elasticsearch works. It uses something called Lucene. And part of what makes Elasticsearch really performant is that it uses these sort of small segments that it writes to while keeping the rest of kind of the index static and available for reads. And then it does this periodic flush, where it's basically getting rid of kind of stale segments, and it's inserting those segments in order that it's just written, and then creates one continuous file out of that. And it's normally a very quick transaction, but that's what kind of enables its speed. When you do this type of operation, it will still continue to sort of add those new segments that come in, but it won't clean up any of the old ones because it doesn't know where you are in the scroll, and it doesn't know where its kind of cursor needs to sort of land on that. So as a result, if someone keeps this for an extended period of time, or you have a very high change rate in your cluster where you're inserting a lot of documents very quickly, you're basically building up a queue of these actions that need to happen. And then at one point, when the scroll gets released, all of those basically come in at once. And while those are going on, your cluster is momentarily frozen. And depending on what your disk performance looks like and your ingest rate, you could kind of create a problem. So these are generally things that you want to sort of avoid. If you really need like this kind of an export, and if you want to do it out of Elasticsearch, like do it as a batch, pick it at a time that's sort of off hours if you have one. Conversely, like in our case, we use S3 as an offload point for a lot of raw data. So when you need this kind of raw data to get that, we actually retrieve it from S3 rather than getting it directly from Elasticsearch again. It's just a better use of the technology and allows us to kind of control our Elasticsearch footprint around this. So at Sophos, we love open distro. There's a bunch of resources here of things that you can kind of take a look at. But in terms of maturing the technology, some of the things that are available around a lot of this, This is kind of the direction that we want to go in. We want to be able to have security. We want to be able to open up these features to more and more people internally in our organization to use it, and then be able to build interesting products on top of that our customers can then take advantage of and use. So I recommend taking a look through these. Now, just in summary and kind of wrapping this all up, if there's a few takeaways to kind of take from this, spend the time to actually build all of the monitoring that you need. Look at the mapping, look at the utilization of the cluster, like really, really understand it, and maintain it, and make that part of your operational discipline. Even if you're using the hosted service from that, this is still your part of that responsibility to kind of maintain that, because you control the application portion of it. So it's very critical to be able to do that. Help your users be more successful with the product. And whether they're kind of internal security operators, they're other developers that you're providing a platform towards, it's other members of your team. There's really good ways to use Elasticsearch that will scale. It'll help drive kind of value in whatever you're building. There are some ways that will cost a lot of money if you kind of go down that road. And then finally, when you're kind of bringing data into Elasticsearch, it's very, very easy to just kind of dump everything. But think carefully about kind of what you want to bring in, what that data's value is going to be, and bring the appropriate things in place. Thanks, everybody.